Well, greetings from Berkshire Guitar Amplifier Repairs. Stuart Smith here in Reading, England, and I've got a very interesting and unusual amp for you today. It's a Gibson Maestro. I've never seen one before. This is from 1961 and it's in absolutely mint condition. So we'll have a look at it in a moment. The customer told me that this is a 110 volt USA amplifier and he plugged it into 240 volts, smelt burning and quickly unplugged it. But amazingly, he said when he eventually got a step-down transformer and plugged it into the correct voltage, it sort of seemed to work okay, which is a miracle really. So anyway, he wants me to have a look through it and see that it's all okay, and this got a very interesting little extra feature to this amp which I'll show you in a minute. Anyway, let's have a quick tour around this amplifier. So here is the front, and for 1961 this is completely immaculate. The grill cloth has got no faults whatsoever. The tweed finish is almost showroom new. I don't know what the provenance of this amp is, whether it's been brought back to spec or something, I don't really know. Anyway, let's have a look at the front. And here you can see it's a fairly simple, very shiny front panel here. Serial number 109901, Gibson logo, Kalamazoo, Michigan, and just got volume and a tremolo speed. Those are the only two controls. Isn't that unusual to have just those two controls, a volume and a tremolo speed on an amplifier? Off, on, fuse, light and instruments. Okay, now here's the interesting thing about this amp. Tucked in amongst all these gubbins here, we have a reverb tank in the bottom, standard spring reverb, and you might think, well, that's a little bit funny. If there's a reverb tank in the bottom there, where's the reverb control on here? Answer is there isn't one. So this amplifier is designed to be used either standalone with a guitar plugged in here and you've got volume and tremolo and I believe no reverb. Actually, I'm pretty sure no reverb. Or you can slave this unit to an existing amplifier into which you plug your guitar, and you crock clip the reverb tank to the loudspeaker of the second amplifier. So you take the signal off the loudspeaker of another amplifier, it comes in through this cable here and into the reverb tank, drives the reverb tank. The wet signal's picked up here and goes up into the amp, and you've got control of reverb here. So you'd have this unit here standing next to your primary amp, and this would simply be giving a reverb sound, and by the way tremolo as well, to the sound coming out of your primary amplifier. Isn't that unusual? I've never ever come across anything like that before. So our task is to make sure first of all that this works as a standalone amplifier, and then we'll need to inject a signal somehow into here. Not quite sure how, because it's going to have to be quite a big signal, and see if when we kick the reverb tank, the reverb comes out of here as well. In other words, check the reverb tank's working. So let's have a look inside and see what awaits us. If my voice sounds a little bit hoarse today, it's because it's 2022 and I managed to get COVID after avoiding it for 3 years, so I'm on day 3 of my COVID jag. So let's take a step back from your computer screens if I was you. It hasn't been too bad, it's just been like a really bad cold. So that's the back panel off. What have we got here? This is the wet signal coming back from the reverb tank. Here we have a foot switch. Not sure what that does. That's interesting. That goes into the reverb tank, the foot switch. So my guess is that quite simply turns the reverb off and on. And now we need to. There's quite a small screwdriver here. Let me see if I've got anything that will fit that. It really is a very tiny screw. to hold on that front panel. Can't believe that's doing all the worth of holding that in there. Huh. I wonder if it's going to be difficult to get this out. Right, if those two little tiddly things out, I bet this doesn't move. No, it doesn't. Right, let's have a little think about how to get this out. Actually, rather surprisingly, this chassis does come out by fits and starts. It's kind of slotted in to a very fine slot in the woodwork there. Very strange design. Come on, you know you want to come out. There you go. Ah, we've got the... Okay, I'm going to have to desolder the speaker leads first. They are soldered in, so I'll desolder those. Okay, that's the speaker desoldered. And now we should be able to... I'll just clip this cable tie. It's quite interesting, this is a black cable tie around it, obviously not original. So it will be very interesting for us to see how original this is, or if someone's been in here before me. Okay, so there's the chassis out. Great. Let's have a look and see what we have got. And here we go. So I think someone's been in here before me. Why do I think that? These capacitors here, I'd be quite surprised if they were original 1960s. This is, that is, that is, all the resistors are. That's an original capacitor. These two aren't. Someone's added those new smoothing capacitors, HT smoothing caps, and these cable ties I'm sure were not there originally. So someone's done the HT caps but hasn't done these other electrolytics. I think we should probably do those. And yeah, so quite a simple little circuit, as you can see. Probably a bit of preamplification, 2 stages of preamp would be my guess, and then this will be the tremolo. Actually, this thinking about it, there's quite a lot of work to be done in this amp in terms of number of valves it's got. It's got one power valve. Assume that's a power valve. Just orienting my way around this. Where's the rectification then, if that's the power valve? I can't see any diodes. Where are you? Okay, a bit of a mystery at the moment. What is this valve? Oh, it's a Gibson valve, look. Look at that, wow. Unfortunately, not sure what it is. Okay, my problem is we only have 3 valves. And we have to do some preamplification, we have to provide a tremolo, we have to recover the reverb signal, and we have to do some power output, assuming that's the power output, and we have to do some rectification. So in other words, we need a rectifier valve as well. I could just go and see if I can get a schematic off the internet, of course, but I just want you to follow my thinking, because this is exactly how I work, so you may as well follow me through on this. So my question mark at the moment is this a rectifier valve or a power valve? I'm erring on the side now of rectifier valve, and let me tell you why. The colour coding for wiring coming out of a valve transformer is actually amazingly standardised. You normally have twisted yellow, or a pair of yellows there for the 5 volt, I think it's 5 volt, heaters. For a rectifier valve they have a different voltage compared to the 6.3 volts. And this looks like, look, the heaters going to this rectifier valve. 2 reds are almost always HT, so look, the HT is going to the rectifier valve. And then we have these twisted pair of greens here, which is the 6.3 volt heaters. It goes to the dual light, and then it loops off around here and goes to the 6.3 volt heaters of the preamp side of things. So that all makes a lot of sense to me and tells me that this is almost certainly a rectifier valve. However, what's this 25 microfarads at 20 volts doing hanging off it? No idea what that's doing, unless they're using some spare pins or something of this valve base just to do some stuff, maybe. And then we've got some HT caps here, 47 microfarad at 500 volts and 15 and 15 at 500 volts, and that's all makes sense, feeding the lower level HT down here. Output transformer, I assume it's this little thing. Oh, it is, yes, because that's where the speaker leads were hanging off of. And that goes to this tag strip here. Right, now what are these valves we've got here? It doesn't even look like an ECC83, this or anything. It's a Gibson valve. Whoa, these valves are original. 12AX7. So this is an ECC83 Gibson brand, which I've never seen before. We'll have to test that to make sure it's working. This is again, it's got, I can see the G for Gibson, EC182. Not totally familiar with that valve. 99.99% of everything I deal with has ECC83s, 82s, 81s, and quite rare for me to get something like this, but this will be another preamp side of things. So my guess is they're sort of somehow managing to get a tremolo out of one half of this maybe, and some reverb recovery out of the other. No idea. I think I'd like to see if I can get a schematic for this. I'm playing a bit of a guessing game at the moment. Right, I've pulled this valve here. It's Gibson, and it says 6130. I don't know whether that would help us at all. Probably not. Nothing else on it. And but it's only got these few pins on the bottom. Look, it's only got 5 pins, so this is definitely a rectifier valve, and I can't see any diodes inside. So this is a rectifier valve. So they are, Lord alone knows how they're doing it. I'm going to be anxious to find out. We have, in 2 valves, we have preamplification, tremolo function, reverb recovery, and power output. Mad. I've just got to know how they do that. Alrighty, I managed to find a schematic online. I don't think this is exactly the right schematic, but it's quite close. And even as I was printing it off, I thought, oh, hang on a minute, we don't need to do reverb recovery as we would normally do on an amplifier, because when reverb is in use, this entire amplifier is the reverb recovery amplifier. So as you can see quite clearly here, here's the spring reverb here, and they just literally switch it in to the very, very first stage of the amplifier. So we don't plug anything in there at all. When this is a reverb amp, the whole amp acts as reverb recovery. So it looks like, I don't know whether this valve complement is correct, but this will be something like this. ECC83 on the front end, stage 1 amplifying either the guitar or the reverb, whichever mode you're using it in, gets passed on to a volume control, bit more amplification in stage 2. I've got a bit of negative feedback here, I think, going around here. And then this goes off to this valve here, which they say is a 6BM8, not a valve I'm familiar with. But anyway, there it is. And it's this valve which is doing the heavy lifting and driving the output transformer and the speaker. Half of it, I should say, is doing that, and the other half they use amazingly as a tremolo circuit with a standard phase shift with 3 capacitors here to get the phase shift around to get the thing oscillating. And that just puts a bit of a waggle on this signal here, up and down like that, to give a little bit of a tremolo effect. So that's what we're looking at here, and of course we have a valve rectifier, which they say is a 5Y3 GT rectifier. So at least we know what we're looking at here. We have preamp in the ECC83. In the other valve we've got half of it's doing the heavy lifting for the power section, and half of it is doing the tremolo. So this is going to be a very low power amplifier. If it's more than a watt, I'll be quite surprised. Might squeeze a couple of watts out of it, but I doubt it. So I think we're at a stage now where I want to try and turn this on, using 115 volts of course, and see what, if anything's working. I mean, he was exceptionally lucky not to completely cook this by putting 240 volts into it. In particular, it would have just taken the mains transformer out. It's still possible that he has damaged the windings on that, but let's hope not, and see if we can get any life out of it. Right, go and find my step-down transformer. Right, here's the beast we're looking for. 240 volts in, and somewhere or other here you plug in. There you go, plug in 110 volts there. And that allows us to power up this amp safely. So let's get this plugged in and the amp turned on and see how it's doing. Okay, moment of truth. There's the transformer. Here is the chassis. I've croc clipped the speaker output there. I've got a guitar plugged in just on the off chance we get any kind of decent signal, and I think I'm just going to turn it on and see what happens. Light comes on, always promising. Valves are alight, I can see that. Yes, I can hear something faint coming from the loudspeaker. Let's just give the guitar a strum. Oh, yep. Oh, and the reverb as well. Cool, that's amazing. This is actually working. So you've got no control over reverb depth, which is a bit weird, and all you've got is control over reverb speed. You know, it actually sounds quite nice. Let me put the camera on a stand and then I'll see if I can give you a demo. My immediate thought is that tremolo, because it's not depth controllable but only speed controllable, is a bit annoying. It's really quite deep, as you can hear. We can change the speed, but not the depth, so you're left with that constant tremolo. And it's very deep, the tremolo. Not very pleasant, actually. That's weird. Why would they make an amp where you've got this really virtually on-off tremolo and you can't control the depth of it or even turn it off? Very flippin' strange. Anyway, this amp obviously breaks up quite early. Absolutely horrible. Hate it. Oh dear. The breakup's nasty and harsh. Plus, with the tremolo on, it just makes it sound hideous. Yuck. Well, I wouldn't give you tuppence for this. Gibson 1961 or not, it's absolutely hideous. Right, let's turn it off. Now the thing is, it's working as designed, I think. Of course, I will put I'll put it up on the scope and see what power it's putting out. I suspect it's putting out full power, which will be a watt or two. It sounds exactly like those Selma amps I had in the other week, which I made some videos on. The only other thing we want to try to do is to see if the reverb tank's working. And I would have thought to do that actually, if I turn it on again and give that reverb tank a good old bash with my, well, with a hammer. Not just any old hammer, of course. What do you think I am? This is my reverb tank banging hammer. Cost £4,000. Woo! I'm liking that. Of course, you're getting that hideous vibrato all the time. So nothing gained, nothing lost. I'm going to try just connecting the input to the reverb tank to a signal generator. And if I can hear anything, I think we can assume the reverb is working. So let's just have a go at that now. Turn on my signal generator, give it a bit of welly, set it to 1 kilohertz, and let's just see what happens if we okay, yeah, we're on the wrong setting on the signal generator. So I'm happy with that. That's my signal generator coming in to the reverb, and so the reverb is working. Well, there we go, there's the output on the screen. You can see it's just starting to square off, and this of course is the vibrato going up and down, which you can't do anything about. So we've got 10 volts peak to peak coming out of the amp before it squares off into 8 ohms. You see it squaring there as I push the input signal. So for cleanish signal we get about 10 volts peak to peak. I'm not convinced this is an 8 ohm speaker. The way to measure a speaker is to put a meter across it and measure the resistance. An 8 ohm speaker will typically measure about 5 or 6 ohms. So if you've got 5 or 6 ohms on that, you know you've got an 8 ohm speaker. If you've got sort of 12 ohms or something, you know it's a 16 ohm speaker. This one's reading exactly 8, which kind of makes me think it's a 12 ohm speaker or something, but I have no idea. Original Jensen speaker. Anyway, this is good enough what we're doing. Let's do the sums now and find out what 10 volts peak to peak into 8 ohms gives us in terms of watts. It won't be a lot. So here's the power calculation. 10 volts peak to peak. Sine wave is 5 volts peak. We multiply it by 0.707 to get the DC equivalent of a 10 volt peak to peak sine wave. That's 3.53 volts. Power is V squared over R, so a V squared is 12.5, R is 8 ohms, power is 12.5 over 8, 1.5 watts, which is about what I'd expect from half of a valve running in a cathode biased mode. So that's really, here look, this half of a valve running cathode biased like this. So that's what we're getting. So I've just discovered, being a bit of an idiot, the tremolo can be turned off by just turning that off like that. So that makes a lot of sense. I just couldn't work out why you would have something with the tremolo going continuously. I just missed this. So there you go, tremolo off, tremolo on. So there you go. Now I've had a word with the client and he wants me to change any electrolytic capacitors which need doing. And I'm also going to check some of those carbon resistor values. So let's do that now and bring the amp up to spec. And with the tremolo off now, I was able to get a more accurate reading on the scope, and without it bouncing up and down. And I'm now getting 12.5 volts peak to peak, 6.25 peak, multiplied by 0.707 is 4.42 volts. V squared is 19.5, 4.42 times 4.42. V squared over R is about 2.5 watts nearest, damn it. So that's actually fairly respectable for this amp to be giving out 2.5 watts. Now before I go on to looking at the resistors and capacitors, I want to just get to the bottom of the business of this valve here, which this is an ECL 32 I believe. I'll just double check that, whereas the schematic calls for a 6BM8. I'm not at all familiar with that. I suspect this might be the same valve. So I just want to find out what this valve is and find out what this valve is and make sure that they are equivalent. because I think the customer said that he had had this revalved at some point. Although that's an original Gibson ECC83 in there, so I'm wondering. Maybe I misheard him. Anyway, let's find out what this valve is. Okay, I've got the gen on the valve. The ECL82 is, as suspected, 2 valves in one. You've got an audio triode, kind of like an ECC83, and then you've got an output pentode, so a sort of power stage output. So this valve was very much in use back in the day, where you wanted some audio amplification and then to drive a low wattage loudspeaker. The 6B-M8 is a direct equivalent to this, so we don't need to worry about that. So there you go. They're using the audio triode part of this to do the tremolo. So here we go. Here's the audio triode part of it. Phase shift, phase shift, phase shift will make this oscillate, and that's doing the tremolo. And they're using the output pentode to provide 2 or 3 watts of amplification into the loudspeaker. Okay, the plan of action is this. There are 3 electrolytic capacitors that need changing. The cathode bypass capacitor for the first stage, 22 microfarads or 20 microfarads at 25 volts. The same one for the tremolo cathode bypass, again 22 microfarads, 25 volts will do there. And then this one here, this is the main cathode bypass cap for the power output stage. So this is this capacitor here, across 620 ohm resistor, and there, look, is the 620 ohm resistor. I also want to check the value of that, because that will affect the power output of this stage. So we'll be checking that value and changing these 3 caps. What's this? Again, that's interesting. That's a 20 microfarad at 25 volts, but so are these. That's rather interesting. That's a huge capacitor compared to these two. Very strange. Anyway, there you go. And then when we've done that, we'll just check around a couple of other resistor values to see that they're not too far out of tolerance. A little bit Heath Robinson this. I don't think this is original, this cable tie here. Yeah, it's not a bad thing to put there. So there is the little arrangement that we want to bypass. So what I'm going to do, just to make my life easy, is remember that the positive is down onto this terminal here. So I'm just going to, I could just clip the capacitor out like this. I think that might be the best way. It's very firmly in there. There we go. And this is a very old capacitor now, 60 years old, so it's well past its sell by date. Now let's just get the meter on that 620 ohm resistor and see what it's reading. Carbon resistors almost always end up going high, so my guess is this will be more than 620 ohms. Let's have a look. 670, look. Yeah, that's not a million miles out. Bit of an odd value, 620. I wonder how they came up with that. And are we happy with 670? It's about 10% over. Do you know what? I think I'm happy to leave that. Not too far out. So all we then need to do is to put this capacitor here across this like this, and that will replace that electrolytic. So let's do that then. Like that. I'm going to put a little bit of flux on here because the those connections are a little bit tarnished. Might help a little bit. There we go. Okay, and we'll solder this up. Jolly good. That's that. Trim off the excess. And because this is flapping around in the breeze a bit, I think I'm just going to do exactly what the last person did and put a cable tie around there to support it. So let's do that next. There we go, that's reasonably stable. Yeah, it's all a bit Heath Robinson, but that's how these things are designed. Right, so the next thing we want to do are these two capacitors here. Remembering that plus is down on that one and plus is up on that one, so I'm just going to make a little note of that. The sort of thing you can get wrong quite easily, or you get interrupted and you come back to it and you think, oh god, which way round was that now? So I just made a little note to myself. Not particularly easy to get in here. It's, I've no idea how they... Yeah, these are really tight in, these. No lead there whatsoever, spare. That's never seen anything like that before actually, to have a capacitor so jammed in there. I think I can just about get in there like that. And just about get in there like that. There we go. That's that one. And you can see it's very old, that capacitor. And it says, what does it say? Translytic Sprague. That's a Sprague capacitor, that. 20. It says 20-6 DC. So is that 20 microfarads at 6 volts? Maybe that's why that's a smaller one and that's big than this big one. So it's at 25 volts. I think it's at 6 volts, this. There. Jolly good. Right, a spot of the old flux on there. Doesn't need much. Solder that in, and then I think I'm tempted to turn it on and make sure it's all still working. Nothing worse than doing loads of repairs. And you turn it on and find it doesn't work, and you think, oh god, which one was it? Well, when I did my final check, I realised I put this capacitor in the wrong way round. Just shows you how easy it is to do that. Slightly distracted by the video, of course, making the video each time, so that's my excuse. I'm sticking to it. So I had to change that capacitor and put another one in the correct way round. So that's now all good to go. I think I'm going to turn it on. And let's have another listen to it with the fact that we can now turn this tremolo off and see what it sounds like. Then I'm just going to check some other resistor values and we're pretty much good to go on this. So there you go, we've got our 12.5 volts peak to peak, no change there. Well, we're on about 1 kilohertz. Let's try 10 kilohertz. Let's drop down a bit. So there's the 100 hertz waveform. Bit distorted look for some reason down at the base. You've got to come down a bit in power to get that clean. Oh, another issue has raised its head. Whilst I was making that previous section, the power kept going on the amp. It just died. I noticed, look, if I had the slightest touch on this wire here, and see that? Off, on, off, on. So I'm not quite sure what's going on there. I'm going to have to investigate. Maybe this connection here isn't very good. Mains coming in here, very iffy, that, isn't it? That needs sorting. Glad I spotted that, otherwise that would have been an ongoing issue with the amp. So I've remade that connection look, and the light's still off, and it's looking like it's this black one here. See that slightest touch on the black one, look. So it was the white one waggling the black one which caused the problem. So now I'm going to have a look at the bottom of this fuse holder connection here and see what's going on there. This is a fuse holder problem, look. If we grab hold of this and just move it in and out, look. It's this fuse holder bit down here. That might mean a replacement fuse holder, which is a bit of a shame because that means it's not original anymore. Okay, so before I go ahead and remove the fuse holder, I notice this component here hanging off the live and going down to chassis. This is called a death cap, and here it is on the diagram, this 0.22 here, 0.022. So-called death cap because if it ever went short circuit, you put live straight onto your chassis. How handy is that? I think these were put in for noise suppression purposes or something. Anyway, we certainly don't need that, so we're going to chop that one out 100% sure because that's a safety hazard. So we'll chop that out, and then we will disconnect the fuse holder, take it out and see if it's salvageable. I sort of doubt it, but anyway, I'd like to salvage it if at all possible. And I thought you'd be interested to see this. There is the death cap removed, and I've put it onto my Mega, which is an insulation tester. It puts 500 volts DC across the cap and measures if there's any current flowing. So when I press this button here, you will see that although it's absolutely tiny, I'm going to release the button now, there is some small leakage there. It's absolutely tiny, but over time that will increase and you'll have more and more leakage through that cap and more AC applied straight to the chassis. So that's why we get rid of those capacitors. So, having gone to all the trouble of removing the fuse holder, I wish I'd looked at the fuse before I did that, and inside this fuse holder was this 3 amp standard UK house fuse. That's no good at all, don't know where that came from. And the proper fuse is this slightly longer one here, look, which obviously allows for more spring compression when you fit the top, which stops this waggling around at the bottom. So it's a bit of a miracle that this ever worked actually. So I've put that one in there and it's all nice and tight, so we can now go ahead and put the fuse holder back, which is good because we can keep the original fuse holder. So that's the fuse holder back in, and it's now nice and solid. Waggle, 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 and we're all good to go. I'm glad I spotted that because I could easily let that go, and the customer would have said the power is intermittent, which it must have been before it came to me. And the other benefit of that was that we did spot the death cap, which I might not have spotted had I not had to have a good old look around here. There we go. So now I'm just going to take some time to check a few of these resistor values, make sure they're not a million miles out, and then we're good to go really. So I've checked the important resistor values here, and they're all high, as you would expect with carbon resistors. They're about 10–12% high. I've taken a decision not to change them in order to leave the amp as authentic as possible. As soon as we start getting in here and chopping out the resistors and putting in new ones, you know, it becomes a lot less original for very marginal change in performance. So I'm happy with the general performance of that. So here we go, we're plugged in, and now that immediately is sounding a lot better without that hideous tremolo. Now of course as soon as we start to drive it, it will break up. raunchy, that, and I don't dislike that sound now. Yeah, it's quite distorted, but that's what you'd expect from a 2.5 watt amplifier. So I think that's probably as good as we're going to get on that. Well, I hope you enjoyed that one. Intriguing little amplifier, isn't it? And like a lot of these very sort of mass-produced in a way, quite cheap amplifiers like Selmer. They had a range of amps, a couple of valves, you know, 1 or 2 watts. Sounds pretty awful. This is a bit much of the same. Unusual in the fact that it can slave as a separate reverb amp, which I've never seen or heard of before. And yeah, it sounds quite interesting, doesn't it? A bit grungy, nice little amp really, and probably quite valuable. I don't know, 800 quid or something these days. So I enjoyed working on it because it was something a bit different, and I hope you enjoyed watching the video. I'll see you on the next one, which hopefully I'll be making soon. I'll catch you then. Bye!